On this video, we're going to be looking at direct and inverse variation. Our objectives are to understand direct variation, to understand inverse variation, and to understand how to determine the constant typically represented by the letter K. Vocabulary is direct variation, constant ratio of y to x, which will typically end with an equation of y equals kx, and we'll substitute the constant in for k. Inverse variation, constant product of x and y, which will typically have an equation of y equals k divided by x. And constant, an unchanging quantity typically represented by the letter k. We'll start with direct variation. Here I have two tables that are showing direct variation. One thing to always look at is how are the x's and y's moving. Notice our x's are getting bigger, 1, 2, 4, 7. Our y's are also getting bigger, 3, 6, 12, 21. This is direct. They're directly doing the same thing. It doesn't mean it's automatically direct variation. That's where using the ratio of the y divided by x comes in. If we check this ratio and all of these have the same ratio, then we have direct variation. So we have 3 over 1 is 3. 6 over 2 divides to be 3. 12 over 4 divides to be 3. And 21 over 7 divides out to be 3. So all of these have a constant of 3. The constant is found by y divided by x. Once we know what the constant is, what we can do is we can use our equation y equals kx, and we can substitute our 3 in for k. We get the equation y equals 3x. What this equation does is it allows us, if we know x, to find y, if we know y, to find x. So now let's go through this a second time with this second table. So again, 2, 4, 8, 12. X's are getting bigger. Y's, 3, 6, 12, 18. They're also getting bigger. They're going in directly the same path. So it might be direct variation. We use our ratio y over x to check if it is direct variation. So we go 3 divided by 2, which is 1.5. We're going to use a decimal on this. We could use the fraction version also. 6 over 4, which is 1.5. 12 over 8, which is 1.5, or 18 over 12, which is 1.5. So it looks like our constant here is 1.5. We could use the fraction version, which is 3 over 2. We wouldn't use the mixed number. We'd use the improper or the decimal. We can then create our direct variation equation as y equals 1.5x. And again, this equation would allow us to predict what a y would be if we know the x, or what an x would be if we know the y. The next thing we want to look at is inverse variation. Now you're going to notice a big change in how the table looks. Notice our x's, 1, 2, 3, 4. They're getting bigger. But notice the y's, 24, 12, 8, 6. They're getting smaller. They're going in opposite directions. Hence the name inverse. Inverse means opposite. So since they're going in opposite directions, we're going to use the inverse knowledge. And in inverse, it said the product of x and y. So we're going to take x times y. And we should see the same number happen each time. Here we're going to go 1 times 24 is 24. 2 times 12 is 24. 3 times 8 is 24. And 4 times 6 is 24. Notice, we constantly get the same thing. So our constant here is 24. In an inverse variation equation, we have y equals k divided by x. So our k is going to be 24, but we use this equation, So we're going to get y equals 24 over x. This would allow us to find y's or x's given what we know. So again, we have another table of this. So notice 1, 2, 4, 8, we're getting bigger on the x side. 8, 4, 2, 1, we're getting smaller on the y side. So this could be inverse variation. We have to test out for a constant to know for sure. Sometimes it looks like inverse or sometimes it looks like direct, but it actually isn't. That's why we've always got to test it out. So 1 times 8 is 8. 2 times 4 is 8. 4 times 2 is 8. And 8 times 1 is 8. So here, our constant appears to be 8. We're going to use our inverse variation equation. So y equals 8 over x. Alright, if there is any part of this video that you didn't understand or you need to refresh yourself on, you can always watch it again or rewind to replay something. So, thank you.